Good afternoon, everybody. First, I apologize for my voice. This is not my voice. I had a really bad cold. So I'll try to get through those 15 minutes with you in here. I'm going to be talking about melee-sized colored stone testing, which is actually something quite challenging and not much talked about. Everybody talks about melee diamond, but nobody actually talks about melee-colored stones. So, in the testing of colored stones in general in a laboratory, there is a range of tasks that you have to perform. They include authenticity determination, so just telling whether a stone is natural, synthetic, or some sort of an imitation. Then you have to analyze the color treatments. I have to see whether a stone is untreated or if it has any type of color treatments done to it. Then you're checking for clarity enhancements, whether it's untreated, fracture filled, impregnated, in the case of jadeite and similar. And then country of origin determination, mostly done for ruby, sapphire, emerald, alexandrite, sometimes for copper tourmaline and spinel. So that's what we do for single stones. Now, what about melee-sized colored stones? In the gem market, small gems remain often untested, basically for economical reasons. And, you know, the market so far hasn't really asked for it much. So much of the material that floats out in the market is never been tested. You get small rubies, small emeralds, small whatever. Nobody really knows if there's something fishy in it or not. But recently, I'd say in the past couple of years, more and more of the major jewelry brands have started to demand exactly that even their colored stones in melee sizes are all being tested. So actually our laboratory has made of it one of its core businesses out of melee colored stone testing, besides diamond and fancy colored testing. Currently, we're testing all sorts of melee-sized colored stones for, first of all, authenticity, color treatment, and clarity treatment. Now, what we don't do is country of origin determination, because that's just not possible in an economical fashion. You can't do it cheaply, because the thing is, important thing is, in melee sizes, you need to be able to do it economically. Let me give you a couple of examples. In corundum, we test stones for their authenticity, for beryllium treatment, for lead glass filling, and for dyeing. Corundum, other testing is just authenticity and full treatment testing. So that's actually sorting out stones that have been treated, untreated, treated in different ways, so we do that. Emerald, authenticity and clarity enhancement testing. Blue beryl, or something many people don't think of really. Aqua versus Maxixe beryl versus its imitations. And then amethyst, that's one of the bigger market problems. We're testing amethyst for their authenticity. So we're currently calling them either natural or undeterminable/synthetic, because often we cannot prove that they're synthetic, but we just can't determine that they're natural. Spinel, authenticity and heat treatment. Garnets, authenticity and species determination. So those are a couple of the tasks that are commonly being done at our lab. As I mentioned before, the most important factor in melee testing is the efficiency. We got to be able to test gemstones very fast in order to keep the costs down. We can't test them the same way as we do single stones, because then we need to be able to keep the costs down. So what do you need to do accurate and efficient screening? There is a couple of points. You need, first of all, the one who sets up the services needs to have extensive experience in gem testing. Second of all, you need instruments that are specifically built for screening of melee colored stones. You need to have an exact procedure for the individual testing tasks, very important. You need a very large sample collections to be able to assure that your screening procedure actually works. Because you're trying to do it efficient, you need to be able to prove that on a very large sampling, your screening actually works. So then last but not least, you have to be able to manipulate melee. And melee manipulating is not easy losing stones is unavoidable when you're dealing with 0.4, 0.5 millimeter stones, but you have to try to keep the loss as low as possible. So let's have a look at the adapted instrumentation. First of all, still, and as always in gemology, the microscope is still really important. Even in melee testing, in melee gemstone testing, the microscope is one of our main tools. So this is, for example, here you see, here you see an amethyst on the cross polarizer in immersion. That's like one way of getting amethysts, natural amethysts out of parcels. Checking for their Brazil law twin that we can see here. So that's very important. Now what we had to do at the laboratory is we had to replace the toxic immersion fluids by non-toxic ones. If you deal with melee all the time and you work a lot with immersion, you really do not want to deal with methylene iodide. That stuff's so toxic, it's going to kill you over time. So you have to replace that stuff with something non-toxic. There is fluids out there, and let me tell you, they cost a fortune. There's fluids that replace diodomethan, methylene iodide. They're very, very, very expensive, but you know, you'd rather have expensive fluids than dying from methylene iodide. Absorption spectroscopy, also in melee testing, quite important. We use UV visible infrared. We have 3 infrareds at the lab. One is equipped with a multi-sampler, so we have multi-sampler accessories and other accessories to run just extremely small stones. Multi-sampler runs 100 samples at a time and can run individually without any operator using it, just filling it up and going outside and letting the machine do the job. Our UV visible system has been made specifically for small stones, so we can run stones of 0.5 millimeters in that UV visible spectrometer. We can run them even at low temperature if you want to. So these are actually instruments. The UV visible has been created by ourselves. So that's like one of the strengths of our laboratory. Chemical analysis also for melee testing, specifically for beryllium testing. Beryllium testing in the yellow sapphires, really important. We do quite a lot of pre-screening. If somebody really wants to know if the stones that are undeterminable via pre-screening are natural or not, then we can test them by LIPS. So LIPS is our method for beryllium determination, and this piece of equipment can handle a lot of stones at once. Now this is actually the 2 core instruments at our laboratory for melee testing. It's those fluorescence, microscopy and spectroscopy systems. So here you basically combine a fluorescence microscope with a spectrometer, and you excite with ultraviolet and with laser. On the left side you see like a prototype at our laboratory that excites with a very high power xenon source and allows us to excite anywhere from 220 to 400 nanometers plus with 2 different laser wavelengths. So that permits us to identify a big amounts of stones per hour very rapidly by doing spectroscopy and imaging at the same time. And on the right side you see the modified prototype of the detect. Thank you. You see a modified prototype of the detect. That's an instrument that's it's built by us and it's being sold by HRD. That equipment also excites stones with ultraviolet plus laser and has a spectrometer attached to it, so it does about the same thing. Now, a couple of images to show you how colored gemstones, a couple of different colored gemstones look like under those fluorescence microscopes. So just visually you can identify what you have. Now here you have a heat-treated blue sapphire. That's kind of a fun one because it has a Pac-Man on top of it. It's heat-treated. So heat-treated blue sapphires, they have quite amazing color, just fluorescence distribution. Sometimes they're kind of artful, so I love to take those pictures. Down here you have a Verneuil synthetic ruby. Normally, obviously, with fluoresce red. By filtering out the red fluorescence, you get the residual blue curved striae visible here. Up here, lead glass composite ruby, very easy to catch by fluorescence microscopy. And here, a resin-treated emerald. So it's also quite easy for us to distinguish between resin-treated and oil or wax-treated, just based on the fluorescence color of the filler. Now, let me see if that one works. Oh, here we go. So we have a software with those two pieces of equipment that allows the operator to actually work independently, not having to look at the screen when he works with spectroscopy. You see the red light down there that tells you something's wrong, and there's a green light down there that tells you everything's okay. And at the same time, what we can't hear now, there is a sound normally, it gives you not just a visual indication that your stones, maybe something's wrong with your stone, but also an acoustic one. So you have acoustic signals which tells the operator something's okay, the stone's okay, or the stone's not okay. Here specifically, this has been done on diamonds, so don't take me wrong, these are diamond spectra, but we do the same with colored stones. So for example, with spinels, we simply put in the chromium line position for spinel compared to ruby, plus the full width half maximum to distinguish between heated and unheated stones and synthetics. And there you are. So we have actually gotten this software programmed to do this type of work for no matter what stone. So we can do spectral analysis automatically, so the operator can work much more efficiently. So let's talk about a couple of results from parcel screens at our lab. We find stuff that really doesn't belong into the parcels all the time. It's not a very, very prominent problem in many stones. Let me talk about what we find. In blue sapphires, we find very synthetic blues. Very rarely, but it happens. Pink sapphire, very nice synthetic pink sapphires. Yeah, it's quite a common thing to find. Ruby, very nice synthetic ruby, depending on the parcels. It always depends who is the supplier. We find more or less of those synthetics in them. Yellow sapphire is a big problem. In many of the suppliers we receive, at the beginning we've gotten humongous amounts of beryllium-treated sapphires in those parcels. And as soon as they realized that we were testing their stones, the amount of beryllium-treated stones got reduced very dramatically, very quickly. So one wonders. Black spinel, that's something people don't really think of testing because it's so cheap. But actually, you find dark blue sapphire, and augite and chalcedony in black spinel. The reason for the dark blue sapphire and the augite is quite obvious. These stones come mostly from Thailand, and it's the same deposits. So that's why they find them in there. Spessartite garnet, we always have mix-ups with hessonite garnet, also with tourmaline, interestingly enough. Rhodolite garnet, we found pink sapphires in parcels. Tsavorite garnet, vanadium tourmaline, obvious thing, because they also come from Kenya. So they often mix them up on site, so that's not something unusual. So we find vanadium tourmaline in such parcels, and from time to time we have found YAGs, so yttrium aluminium garnets, synthetics. Amethyst, big problem to identify. We find synthetic amethyst and stones that we cannot determine as being natural very frequently. Aquamarine, we find blue topazes, and in emeralds we find quite a bit of resin-treated stones, and they're supposed to be oiled only. So conclusions. Besides diamond, melee diamond, and particularly fancy color diamond, the screening of melee-sized colored stones has become really one of the core businesses at the GGTL labs. We are in a particular position as a lab because of our innovative machines, designed and built by our lab. So whenever we have to adjust to some procedures to identify something, we can actually just build the machine around it, which is really a comfortable position, or at least try to find out something that can solve our problem. In the past years, those hundreds of thousands of small stones have actually shown that this service is really important for our industry, because not only in colorless diamonds and fancy colored diamonds we have synthetics and imitations, but in colored stones it's exactly the same problem. We have found that the biggest and most severe problem is yellow sapphire, amethyst, and black spinel. In all others, it's relatively irregular and not such a big problem. And with this, I thank you for your attention.